Hello everyone, today let's solve LeetCode 226 invert binary tree problem on DKodeTree. This is an easy one but a great problem to build your understanding of trees. So let's look at this example. Given a tree with root node 4, we need to change the positions of the node in such a way that the right child of the root, that is 7, becomes the left child and the left child 2 becomes the right child. We can see this swapping clearly in this tree. But notice that the same inversion operation happens for their children further. We can see that the node 2 has two children, 1 and 3. But in the result, the order of 1 and 3 are flipped. So we need to apply the same operation to every node down the tree. Now there are a couple of ways to solve this. You can either use DFS or BFS, but the recursive DFS solution is the most natural and the intuitive one. And one important note, when we say swap, we are not just swapping the values. We are swapping the entire node. That is, say this is node 1 and this is node 2. So we are not just swapping these values, but we are swapping the entire nodes, which includes the value, left child, and the right child. So when we say that we are swapping 2 with 7, we are actually swapping the entire subtree rooted at 2 with the subtree rooted at 7. Now for the recursive DFS solution, our implementation also depends on the DFS order we choose. If we use the preorder DFS, we will swap the nodes first and then let the recursion process the children. And in the postorder DFS, the recursion will first process the children and then we will swap the nodes. We can solve it either ways. And as we will visit each of the node at least once, so the time complexity will be O of n. Also, as recursion uses an internal stack, so the space complexity will also be O of n. Alright, now let's dive into the code and see how it works. First of all, we will check if the root exists or not. So if the root is none, we will directly return. Otherwise, say we are doing the pre-ordered DFS, in that case we will swap the nodes first. So for swapping, we can take a temporary variable in which we can store the left child of root and then assign the right child to the left child. Finally, we will store the temporary variable to the right child. So one way we can reduce this code is by using a very simple Python syntax in just one line. Root.left comma root.right is equal to root.right comma root.left. This is the Python way of doing swapping very easily, where a comma b is equal to b comma a. Now after swapping is done, we will simply do the recursive calls on the left and right subtree. We will call the self.invert tree on the root.left and same we will do for the root.right. Finally, we will just return the root. Now let's check if this works. This works well and it's quite efficient. So now let's also try the post-order DFS version. Simply tweak this code. Here we will just do the inversion first. Copy this line and paste it here and this one here. This is the post-order version. See what is happening. Here, first we will be inverting the root.right and the root.left and then they are assigned. Then we are assigning the inverted subtree of right child of the root to the left child and the inverted subtree of left child of the root to the right child. Now let's run this as well. This also works fine. So this was all for this problem. If you found this helpful, hit that like button and subscribe to DKodeTree. Thanks for watching. See you in the next video.